If it's a code problem, it says if the following instructions are carried out by a computer, what value of x will be printed as a result of the fifth instruction? All right. So I have this written down, and it's here for you if you want to copy that down now. But I'm going to go to the whiteboard and kind of read over it. And the problem for me reading over that is to figure out what's happening with this computer code over here. So the first thing I'll do is like an initialization step in the problem. And I'm going to start with 0 for the initialization. So I'm going to say x, the initialization value for x, it's 3. And the initial evaluation of s in the computer is just going to be 0. Then someone says, what happens? There's an instruction that's followed. It says, increase the x by 2. That would give you 5. And then it says that the s would just be increased by the value of x. That's 0 plus 5, which is, let's put 5 down. That's not so bad. And then it keeps repeating, by the way. x2 increases it by 2, you get 7. And then s2 would be 5 plus 7. All right? And if I keep doing this, like x3, there's going to be someplace stop. It's not an infinite loop. It's going to stop somewhere 9. And then it says s3 is equal to 5 plus 7 plus 9. And what's nice about this over there, at least the x's, by the way, is arithmetic. And what's it going to eventually get to? It's going to get to this nth step. And what's that going to equal to? Well, it's going to equal, let's see, the initial value is 5, and then it's going to be n minus 1. We'll check it, by the way. And what's the d going to be? 2. So if I were to look at that, what would I get? Well, let's take a look. You get 5 minus 2, which is 3. Let me be careful here. So 5 minus 2 is 3, plus 2n. I'm going to check it by my numbering. And by the way, you could choose a different number. I'm not saying that you have to start with 0. I just did in this particular run of the model. You could initialize it anywhere you want. You can say x7 is going to be 3 if you want. But let's take a look at it. And if I put a 1 there, would I get 5? Yes. If I put a 2 there, do I get a 7? Yes. A 3 there, do I get 9? Yeah. So it looks pretty good for me. So I'm going to write the s now. I'm going to write sn down. And what's that going to be? It's going to be 5 plus 7 plus 9 plus 11 plus 13. I'm going to say yada, yada, yada. But it does stop somewhere. It stops at 3n plus 2. So I'm going to put this below it. I'm going to write down 3 plus 2n. And that's the last term, by the way. I go down by 2 now. So it's 1 plus 2n. This sort of like reminds you that you've done this in pre-calculus, by the way. And it's going to be, let's see, I'm going to say 2n minus 1. I'm going down by 2. And then 2n, minus 3. Now, the reason I like to do this, I like to look at the pattern in the problem. So, like, I'm saying there's going to be like sort of like a pairwise matching in it. All right? So, 5 plus 3 plus 2n is 8 plus 2n. And the next one also is going to be 8 plus 2n. And I'm going to say there's going to be pairwise matching. We do it by induction, but n over 2. All right? And I'm going to say that really kind of simplifies pretty nicely. It simplifies to n, and then 4 plus n. And what do I want this? I want this to be somewhere around the. Again, this word things get kind of like maybe misunderstood, but they say that once that Sn, it says if Sn is at least 10,000. Well, I'm going to try to figure out when it's like 10,000. Put this over here. So when is it? Like I'm going to say close to 10,000. Well, kind of looking at that, and I'm going to say, let's say we tried 99. Right, n is 99. And what would you get there? You get 99 times 103. Let's see if we can do that. So 99 times 103. It doesn't look that bad, by the way. I want to see what the number we get. Well, you can get 27, and then you get 9. So you get 7, 2, 9 again. 7, 9, 11. Well, that's certainly over 10,000, right? So The question is, what happens before that? Be 98, right? Let's write that down. What do you get? You get 98. But I'm doing the sum over here. I'm just doing this. And then it's going to be 102. Well, I'm going to write that down now. It's going to be 98 times 102. Well, let's do that. 8 times 2 is 16. And then you get 8, 0. 9 times 2 is 18. And 9, 6, 9, 9, 9. That's definitely below 10,000. So I'm going to say somewhere around 98, it produces a number below 10,000. So I'd actually go to 99, right? I would go here, right? Because what happens here, S is at least 10,000 now when I go to 99. Then it says, if I'm at that number where it exceeds 10,000, it says go to instruction 5, and 5 says print X. So I'm going to print it out now, right? So what am I printing out? I'm going to print out 3 plus 2 times 99. Right, and I got to do the arithmetic over here. So it's 3 plus, well, 2 times 99, 180 and 18, 198. And 3 plus 198 is 201. So what's going to be printed out? 201. All right, let me read the rest of the instructions, though. Oh, stop. I'm stopping. I just printed out 201. All right. Now, granted, there's a variety of ways of doing the problem, but X would be 201 in the problem. Thank you.